Hello there, we're back. We've been looking at correlation coefficients and measuring the strength of a relationship between two sets of data. So I have a bunch of clouds here, and these are my possible correlation coefficients, and I just want to match them up. So I always start with the most extreme cases. This one over here is very extreme. So it's trending down, it's got to be negative, and I got to pick the most negative one possible, so that's going to be that one. It's a very tight oval, and as I can see, then I got to write a sentence that always has a strength and a direction. So this is a very strong negative correlation. Okay, looking for some other cases. We have one up here that's the most positive. So I'm looking for something that trends upwards and is fairly narrow and tight, but not as tight as this one. So let's see here, cloud, that one's trending down, that one's trending, this one up here is definitely trending up and it's fairly tight. So I'll call that one a strong positive correlation. If you say very strong, no one's going to bat an eye. So we've eliminated those two. And let's keep going here. Let's see here, what's another good choice? This one has to trend down and be fairly tight together. So that looks like that's got to be that one, because this one's trending up and these two look like they're weaker correlations than that one. So I want to mention on this one that actually this is still a strong correlation. Well, 0.7, negative 0.7, that's borderline moderate, but just because something is fatter than another thing doesn't mean that it can't be a strong correlation. Okay, so now we have some harder choices left to go. That one's out. This one is going up, and there's only one left that's going to go up, so this is a bit process of elimination. It's fatter. It can be a little bit hard to tell, you know, is this one really fatter than this one? But those points are more spread out. This has a better oval shape. And then we're left with these two. And they both look like clouds, but this one's cloud trends ever so slightly down, whereas this one, it's hard to tell, is it going up, is it going down? So this one is going to be even weaker than this one. This one's going to be close to 0. And the other one over here is going to trend just so slightly down, but it becomes more of a nebula, more of a cloud, less of an ellipse than the other ones. I'm also going to point out that all of these are elliptical in nature, which means that they approximate, the approximation for the model is going to be a line from which it fans out. So this one up here, it is close to this line, but it's a strong correlation. It's going to be fairly tight to that line. As the correlation becomes more moderate, the points spread out from it. My correlation gets closer to 1 or negative 1, those points are going to be very, very close to that line. If it's 1, it's going to be exactly on it. And I got those two. It can be a little bit hard to tell on this one here which way it's tilted, but it's ever so slightly negative. And the last one, I really don't know. Is it flat? Is it going up ever so slightly? Is it going down ever so slightly? Where's the major axis on a sphere? Hard to know. Okay. Character and scholarship for life.